Hi, GI.
Hi.
Hi, how are we doing? Are you keeping okay?
Yeah.
Good, excellent. Yeah, sorry for today because I thought you'd gotten the earlier message when I said, can we start at 6? I wasn't sure whether we were still on because I hadn't heard from you or your mom. So I thought, let me just double check we're still on because my daughter has got a test tomorrow. So I was going through some maths with her and we haven't quite finished just yet. So we're still going to do some more maths together, but it doesn't matter. So I said, let me just double check because if it's not, then I'll carry on helping her with her maths. But obviously we are on, so that's fantastic. Good. Have you gotten any of your results from your previous tests?
Not yet because they're all going to do it for the people who haven't done it. So this week, and then they're going to give it back on Monday.
Oh, wow, they're waiting for everybody to. Yeah, of course, they're going to do that. They are going to do that. Okay, no problem. Right. So I'd sent you last time some problems with algebra and shapes and that. Did you get a chance to go through any of those problems? I'd also sent you, of course, the answers so that you could self-assess once you'd finished. Did you get a chance to do so?
Yeah, I didn't go for all of them. I went for a bit of them.
That's fine. You don't even have to go through all of them. You can leave some for later practice, and it's actually encouraged so that every so often you practice different types of skills, because what you don't want to do is you don't want to leave it too long, and then because you did so much, you finished all the questions, and then you leave it so long, and then you still find that you're still going to be rusty. So there's something known as what is it called? There's a word for it. It's something, it's not quite it's like memory decay or knowledge decay. Like when your knowledge is not being used for a certain while, it decays, a bit like radioactivity. Yeah, so every now and again you need to kind of top it up, so to speak. Right. Okay, so thank you. Now Wednesday, I was just going to let you know that I'm taking students from my school. We'll be out in London for 3 days, and then we'll be off to Oxford. So I will not be available from Wednesday up until, well, Friday really. So this Wednesday won't be possible, but if you desperately needed a lesson, then we could of course do it over the week, and otherwise we could just then resume as normal the week after.
Mm-hmm.
Does that sound okay to you?
Yeah.
Okay, super. Right, without further ado then, let's look at some polygons. Might involve a few equations, but of course you were practicing, so hopefully you might be able to work your way through that one. Now, whilst you're doing that, I just need to get my actually, no. These are all non-calculator questions. They're all non-calculator, so I will not be reaching for my calculator.
Wait. Would it be 60 as well?
Would it be?
60.
Not quite. a bit of a nasty problem, this one, because of course, key thing to note is that this will not be at the center of the pentagon.
Yeah, I was thinking that too, but then
Yeah, so that's
yeah.
the key thing. So this is not the center of the pentagon.
I'm not really exactly sure.
If it was the center of the pentagon, different, and also you would not be able, this would not be 60 degrees. You cannot form an equilateral anyway. If it was a hexagon, however,
yeah,
if it was a hexagon, then now you can form equilateral triangles. Okay, and all these would be equal, but not for a pentagon. Okay, you get the idea, so on and so forth.
Yeah.
Okay.
Actually, I'm not really exactly sure of them.
Not exactly sure. Okay, so just try and use all the information that's given here to try and break down the problem. So is there a trick somewhere that you have overlooked?
Yeah. Well, ST and SU would be equals to like all the sides in the.
So you're saying, very good, you've spotted the trick. Now it should be easy to work it out.
And then STU would equals SUT.
Very good. Very good.
And then I did so like STUR is a kite. So I thought the two opposite angles would be the same, but wasn't sure.
So you've said that this would be, but it could only be a kite if this length was the same as that length.
Oh, yeah. Yeah, I think after that I got a bit confused. So
Okay, so can we write down what we know? Or can you see another way around it? I'll give you a few seconds to try and see if you can spot another way around the problem.
I think like, is it so like, do I need to work out the interval? Wait, so if so would I say TSR is 108?
So TSR, you said very good. And this is the whole point about when you're faced with a problem that seems like it's stumping you up a little bit, you write as much information as you know. And in so doing, you are dissecting the problem and seeing tricks. So this here would be 180 degrees. Good.
Oh, I get it. And then 108 take away 60 would equal
Fantastic. So we've put all the information we know. So this here is 60 degrees. It's an equilateral triangle. So what is this value of this angle?
so it'd be 66 each for each one.
Correct. So the answer is D. You got there in the end. It was just a case of really just being ultra observant with the information and trying to put in as much information. But at first sight, it really is or does seem puzzling. Yeah. All right, good. All right, try another one. There we go. Test on simultaneous.
Would C equal, wait, 6 out of 6. Would it be 39?
Well done. Excellent. Good. Okay, number 6.
Would it be line 1 and like 1 and 3?
So you've mentioned, so it's going to be one of them with line 1 in there, you say, yeah?
Oh, I think 1 and 3.
1 and 3.
Yeah.
You're spot on. Excellent. Super going. Good. Okay.
What do you mean -9?
-9 for that one, you got?
Yeah.
Not quite. So let's just see where we may have. So your expansion, you started off, so you've got 2x plus 3 squared minus x minus 3 squared. If I expand this, remember my little trick?
Mm-hmm.
So the first term would be 4x squared. What
Yeah.
would the middle term be?
It'll be 4x squared and then it'll be 12x.
Correct. 2 times 3 times 2x. Good. Last term, square that.
No.
So that is for this part here. What about this part here? If I expand that, what does that become? X squared.
X squared, take away 6x.
Good.
9.
Very good. So then I'm taking away this minus. Yeah. Now there's brackets, so I've got to expand this, haven't I? Oops, wrong color pen. So we've got our 4x squared plus 12x plus 9 minus x squared plus 6x minus 9. Yeah?
Yeah.
Cancels out. So the expression you probably would have ended up with, would have said something, oops, 4x squared, no, sorry, 4x squared minus x squared is what? 3x squared, isn't it?
3x squared.
So 3x squared, hang on, 3x squared plus 18x. Oh, you're right, you just double check. Minus x squared, yeah, plus 6x, yeah, and a minus 9 there, yeah, yeah. Is this what you got then as your expression?
Yeah.
This was your expression?
Yeah, no, I forgot about the minus sign, so I didn't get that part right.
So let's just have a look again then. Where have we folks heard?
Oh, it's because when I expanded the second one, I forgot about the minus sign, so I got minus 6x. Is that
Oh,
one
I
subset?
see, I 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 see. I see exactly what you're saying. Okay, so from this stage now, what can we do?
Pretty sure you halve the second term and then you square the term in the middle, and then you get expand like.
Yeah, you know the procedure, but when you've got a number in the front, the game changes a little bit, doesn't it? If you've got a number in the front, the game changes a little bit. So if it was just like this, I'm just going to give you an example just so you kind of recap this, because especially if you haven't done it in a while, right? So imagine you had x squared plus 6x plus 11. Well, we can't factorize this easily. Yeah. So if we're going to complete the square on this, because the coefficient of x squared is 1, this is nice and easy. All you simply do is divide this term coefficient of x by 2. And all you do is you would rewrite them. This is x plus 3 squared. 6 divided by 2 is 3. Yeah. And then all you do is you expand this and then look to see the difference between this expansion and that top term in terms of we're looking at, do we add something or do we subtract? Well, if I expand x plus 3 squared, it's x squared plus 6x plus 9. So to go from the only difference between this expression now and that expression is that they're out by 2. So I need to add an additional 2 here to make this 11. So all I need to do here is put a plus 2. Now I've completed the square. Are you happy with this?
Yeah.
But when you have a number at the front, the game changes. You can't just divide by 2. So here is a bit of an example. So which one can we go for? All right, trying to find these now. Think of prime 3x squared plus 12x plus, let's say, I don't know, 39. Now you can't just divide by 12 here. You can't do that. Yeah. So you can't just divide the 12 by 2 because there is a coefficient of 3 next to it. So you could do one of two things. You could either firstly factorize the 3 out. So this would be 3x squared plus 4x plus, what's 3 to 39? 13. Yeah.
Yeah.
And then now you deal with this. So now the coefficient here is 1. Then you'd say 4 divided by 2 is 2. So you then say x plus 2 squared.
Yeah.
What would be the next thing I would need to add to get what's in the brackets? So what term should I add to this to get what's in the brackets?
13.
Would it be
13.
not quite. I wouldn't put a plus 13 if I want. So if I expand this, I get x squared plus 4x plus 4. But I want to get this thing in the middle. So what is missing for me to go from here so that I can get that? What do I need to add to this expression that I've expanded from x plus 2 squared? What do I need to add to it so that I can have what's here?
You add 9.
Correct. So I'm going to put that 9 here. You happy with that?
Yeah.
Good. Then remember that these are brackets and we have a 3 outside. So the final step is I take this 3 and I multiply it to the 9 and leave it outside the brackets where we've got the x plus 2 squared. So my final answer would be 3x plus 2 squared plus 27. These things are the same. Did you follow that?
Yeah.
Good. We can even do it even in a much easier way. I was just making sure that you understood this method. We could make our life a little bit easy if I just insert So what is it? 3x squared plus 12, blank page after current. The other thing we could do is we could just really concern ourselves with these first two terms. We don't need to worry about factoring out a 3 out of everything. Just simplify the first two terms. So you can take out the 3, you got x squared plus 4x. Yeah, and then outside here we've got plus 39. Following?
Yeah.
Good. Then now we deal with this thing in here. So if I deal with that thing in terms of completing the square of it, just what's inside, what do I now have? I'm going to have x plus 2 squared. But hang on, if I expand this thing here, x plus 2 squared, I get x squared plus 4x plus 4. So for this, what can I do to this to make it look exactly like this? What can I take away or add to this expanded form so that I get this? Minus 4?
Yeah.
Correct. So I put a minus 4 there. Remember that all of this is being times by 3 because this is the same as that.
Yeah.
And I have a plus 39 on the outside. The next stage is to simply take the 3 and times it to the minus 4, but leave it outside these brackets. So I get 3x plus 2 squared minus 12 plus 39. And my answer comes out the same as when we factored everything out, which is the same as the answer we had previously. Sorry, this should say plus 27. I don't know why I rushed it here. Yeah?
Yeah.
Take it, Ibu. So now your turn to try and have a go at this one here.
Sorry, do you mind if you just go through it one more time and I'll just write it, make some notes as well. So it's okay a little bit.
Which particular one do you want me to go through?
It's just the method again because I got a bit confused like with my note.
Okay, that's fine. Do you want me to go through one of the examples I've just used?
Yes, yes, please.
Yeah, so I can leave you with that one to try to really see if you've understood. Excellent. So which method do you want us to look at in more detail? Method 1 or method 2?
Yeah, the second one.
The second one, okay. So what you do first is you only concern yourself with factoring out a term from the first two terms. That's the first thing we do. So we picked a 3, x squared plus 4x. We left that as it was. Then we completed the square just on this alone. So we took, because the coefficient now is a 1 there. So take 4 and divide it by 2. And we get our x plus 2 squared. We then expanded it to compare what the expanded form of it, how does it compare to what I actually have in my brackets? And what can I take away therefore or add to this so that I end up with the form that is here? And we knew you need to take away a 4 because constant here is a 0. And this now is all in brackets because this thing that is in these square brackets is equivalent to this thing in these curly parentheses. Are we happy? And we still had our 39. The next stage, we took the 3 and we multiplied it to the -4 only because it will be outside of the x plus 2 bracket squared.
Yeah.
Okay. And that was the 3 times -4 minus 12 plus 39. 39 minus 12 is 27. And that is how we ended up at our final step.
Yeah, I think I get it now.
Okay, good.
Would it be 3 brackets x plus 3x squared to take away 9?
So, okay, steps wise, you took away the 3 and you have, okay, it says where p, q, and r are constants. So you have x squared plus, what do you have in there? 6x?
Oh no, yeah, and then 6x. That's it.
Good. So if I divide that by 2, so I've got something that says x plus 3 squared. Yeah. And if I expand that, what do I get?
Well, so
if I expand the x plus 3,
yeah,
if I expand that, what do I get?
You get x squared plus 6. Oh wait, no. Yes, 6x
Plus
9.
Plus 9. Good.
Yeah.
But hang on. I want to make this to look like what's inside the brackets. So what do I need to do to this thing to make it look like what's inside the brackets?
You add 9.
Add or take away?
Oh, you take away 9.
Thank you. If I take away 9 from here now, this thing I'm going to put in square brackets is identical to that thing above in these curly brackets. Are you happy with that?
Yeah.
But there's a 3 outside here. Yeah. So what's the next thing? But let's look at the form given. The 3 is on its own. It's not like they've told us that it looks like this, x plus q squared plus r. So what do I need to do as my next step from here? Any ideas?
Not really sure.
Okay, so remember that step here we took. When we came here, what did we do? We just didn't leave the 3 outside and put square brackets. We took the 3 and multiplied it out to that one. That's how we got this -12 here.
Yeah.
So what do you think I'm going to do here now? What do you think I'm going to do to find r?
You just find -9. You times
No,
it by 3.
yes,
then,
thank you. It's -9 times by 3. Now I can rewrite this as 3x plus 3 squared minus 27.
Yeah.
So the value for r is?
Yeah, -27.
Tough, but as long as you followed it, I'm hoping you've learned a thing or two.
Yeah.
Yeah, good. Number 12.
We see.
For that one. Sorry, have you just spotted something?
Oh, yeah, would it be
Would it be
C?
C? Okay. So tell me how you went about doing this one. Not quite. So
In a
tell
way,
me,
I guessed, but like I kind of did so 250, 700%, so it'd be 250 times 7.
so did you
So
write an expression first? Did you write this out mathematically?
no.
You need to do this because this is proportions.
Okay.
Yeah, so the number of pairs, how do you write that? Would you put your symbol?
Yeah.
And then you'd be looking to find constant is inversely proportional to the cube of the outside temperature. So what would you then write?
1 over
1 over
x.
I wouldn't call it x. It says is proportional to the cube of the temperature. I'll use something 1 over t. What?
Yeah.
Just 1 over t?
Yeah.
No,
Degree
but look,
Celsius?
well, not quite. It says inversely proportional to the what?
To the cube of the x.
So what does that mean? What's cube?
So cube root t.
Not cube root. Means t to the power of 3. Cube root means t to the power of 1 over 3. Or that's what cube root means. But cube means that.
Mm-hmm.
Do you reckon you can proceed from here now?
Yeah.
Have another go.
Would it be D? Wait, so let's just
D.
D.
So next step from here, did you say that n is therefore equal to a constant over t cubed?
Yeah, I did that. Yeah.
Good. So then we have n as 250. And we have, oops, this here as 8.
Yeah.
So what did we get as 8 cubed? 64 times 8, 2, 3. That. Of course, it's non-calculated, so it's going to take us. So then K is n times t cubed. So we've got 512 times 250. That's the value of K. Are we happy? Did you get that as a value of K?
No, not really.
Okay, but can you see how that is the value of K?
Yeah.
Or why it is the value of K?
Mm-hmm.
Good. So then what was the next step? So you want to find T, don't you?
Yeah.
So they're saying the next day, what is the value of X? X here is the temperature. So I know that T cubed is equal to K over N. Yeah?
Yeah.
I've rearranged this. So what's my K? It's 512 times 250. Oops. Over N. It says 700% more.
Yeah.
So that means, what is 700% more of 250?
So 250 times. So that would be 1,750.
Sorry?
1,750.
Okay, so what did you multiply the 250 by?
7.
By 7?
Yeah.
Do we times it by 7? So let's just take a think. If I told you that I sold 50% more shoes. Let's just keep the work from a simple one. The next day. How many would you say I sold the next day?
I would say 375.
Thank you. You'd say 375. And how did you get that? Well, to get that, the simple way to think about it is you divide 50 by 100, which gives you 0.5. And then you add that to a whole, which is 1, which gives you 1.5. So to find the number that you sold the next day, you do 250 times 1.5.
Yeah.
Okay, we'll use the same logic here. If I sold 700% more, firstly, I'm going to divide the 700 by 100, which will give me 7. And then I'll add that to 1, which will give me 8. So my multiplying factor becomes 250 times 8.
Yeah.
Does that make sense? Are you right?
Mm-hmm.
Good.
Mm-hmm. I think.
Now, what do we see here? These two do what?
These two
Cancel
cancel.
out. Good.
Yeah.
I've still got a t cubed this side. What is 512 divided by 8?
Uh,
Don't worry if you can't do it all in one
64.
go. Again, I'm building your mental arithmetic skills. 4 into 8 is 2. They're all even numbers. 4 into 5 is 1, leaving 1. 4 into 11 is what? 2,
Yeah.
leaving a 3. 4 into 32 is 8. So now I've got 128 at the top and the 2 at the bottom. What is 128 divided by 2?
64.
Correct. So now I have t cubed equals to 64. Therefore, t is what?
So it'll be 8.
Take your time. So t would be the cube root or
Oh, it would be
64,
4.
which would be 4.
It would be
So the
4.
answer is B. Did we follow that okay?
Mm-hmm.
Good.
Mm-hmm. Yeah.
So here, most importantly, don't get caught out when something has increased by percentages. Percentages confuse a lot of students, but if ever you're stuck, Jay, I hope you notice I was modeling me being stuck and or trying to understand what should I do or how should I deal with the 700. Find an example that is nice and easy that you can relate to, and then try and apply that in the more complex scenario. All right. Okay, next one.
Um, it looks so complicated.
Take your time, take your time, take your time.
Yeah. Would it be, I think, F?
F. You say
Mm-hmm.
F?
Mm-hmm.
You're absolutely spot on. Now, was that a guess or did you actually do some working?
I worked it, I think.
Very good. Way to go. So it wasn't so complicated in the end after all, was it? It
Yeah,
just looked
I got a bit.
intimidating, just like all the expressions, and then you've got so many options and you think, what's going on?
Yeah, it was all the sign and cost that made me really confused. I was like, ah.
Yeah, good. You got there in the end. Well done. Awesome. Okay, now here's one.
I'm not really sure about the constant part. It's like two solution. There's a constant.
Yeah, it says where P is a positive constant. Where P
Yeah.
is a positive constant. What is the value of P? So we told that the quadratic equation 2x squared x minus px minus 4 has two solutions that differ by 6. That differ by 6. So in other words, what do you normally do if you are going to, well, in this case, we don't know if this is something that you can easily solve in the sense of, can you easily factorize it? We're not too sure, are we? Because normally if you have something like, I don't know, I'm just trying to give an example here. Can I think of something like 2x squared, can I try to think very quickly here? Minus, okay, so here let's say we have minus 4. Sure. Okay, so we've got 8. Yeah, minus 2x. Let's say I had something like this.
Yeah.
And you had to find the solutions to this equation. Well, what would the solutions be? Normally what we do is firstly we times these two terms, so we get minus 8. Then we'll be saying, well, I want two terms that when times together give me minus 8, but when added together give me what? Minus 2. Yeah? Do you remember this method? Hello, can you still hear me, GI?
Yeah.
Do you remember this method?
Not really. I don't think so.
Okay, right. So you find 2, I think I've gone through it with you, minus 4 plus 2, and then you take these two terms. This is how you factorize quadratics. So how would you factorize a quadratic like this at school? How would you do this?
Oh, no, I don't do it like that. I kind of just look at it. I didn't really do the boxes.
So do you do like a guesswork to try and guess which numbers?
Oh no, I don't guess it. I just go like 2, 4, and then I do it like a tree diagram. So like, and then it just branches. It's similar, but like it just don't write the boxes. So I think it's the same thing. Yeah.
Okay, I think it's the same thing in essence, yeah. So you got 2, but would your next step then be rewriting this as 2x minus 4x plus 2x minus 4?
Yeah.
Same thing. Correct.
It's the same thing. Yeah.
Yeah. And then of course here you'd say your 2x, x minus 2, x minus 2, and then here you'd have your 2, of course. So you get 2x plus 2 and x minus 2. So you'd say that your two values of x would be x equals to 2 or x equals to minus 1 in this particular case. Yeah?
Yeah.
So this is like now me telling you to say the solutions of my equations differ by 3. And I want you to work this term out, the middle term. So now you're working in reverse. So how can you start without knowing these two values, just by knowing that they differ by 3? How can we end up there?
Would you times it by 2, so it'd be 4x?
Would you times this 3, sorry?
Because it differs by 3, so would you like square it so it's 6? Like you times it by 2, so it's 6.
And then what are you going to do with the 6? Remember, we want to end up with this. So we're creating a problem. We know the solution because we started off here, solved it. So now we're saying, imagine the question. In the question, we don't know this number and we don't know this number, but we know that these two numbers, they differ by 3 because 2 minus 1 is 3. How on earth can we go from just this piece of information to being able to work out that the value here is 2? That's what we're saying. Is there a pattern we can see? Can we replay this in reverse and try and work out how we can get to that 2? Does that make sense as to the question I'm asking?
Yeah, I think so.
That's the problem we're faced with here. That's the challenge. Yeah?
Yeah.
So try and think about this one. I'll leave it to you as a little bit of a homework problem. It's always good to have good thinking problems for homework. Try and think about this one because it's a nice little puzzle. And I think you'll be very satisfied when you work it out yourself. But if you don't, then we're going to look at it in more detail. How does that sound? Is that okay?
Yeah.
Good. All right, here's a nice little one then.
Would it be E9?
Would be E, correct. Well done. What a way to finish. Excellent. Good. So still got one little puzzle there to try and work out. Just remember that as your little homework task. Now, is there any particular extra work you might want to go over or revisit or just consolidate that you might want to kind of touch on? And I can send you some extra work on that.
Is it okay if the next lesson we go through some like histograms and like the medium range, stuff like that? 'Cause I get
Yeah,
really
so you want to go through next lesson, you want to go through histograms
confused.
and what else?
Yeah, like the medium range and then like mode, stuff like that.
Yeah, absolutely. Yeah, cool. Cool. Okay. So really it's touching on statistics, isn't it?
Yeah.
No problem. Right. We're going to go through that and we're going to try and make sure that we collate some good questions so you can be stressed and challenged, but at the same time feel like you really understand it to a good degree. Good stuff. Right. Unless you have any further questions, GI, that was really, really good. Well done. They were some really hard questions there. But you know, the key thing is you tried your best and we talked through most of them apart from the homework problem. So hopefully all that is building your mathematical capability. Well, I'm sure it is. There's no doubt that it's not. Looking at doing problems like that in the long run will only make you a very strong mathematician, which is good. Awesome. Have a lovely, lovely Monday evening, and thank you for your flexibility today. I'll go back to teaching my daughter and trying to help her with with her test tomorrow now. But I look forward to seeing you again. So next week, Monday?
Yeah.
All right then, no problem. See you on Monday.
Thank you. Thank you
Cheerio,
so
you're
much.
welcome. Nice, and thank you. Bye. Bye.